Now let's talk about integrity. Integrity as part of the CIA Triad ensures that data is not tampered or altered. Common integrity attacks are data tampering. So this happens when someone changes data. For example, someone changing the grades of students in a school's database. So somebody scores 70, they change it to 40 or 40 to 70. You know how disastrous that can be. Also, DNS spoofing. I'll take a moment to explain what DNS is. DNS is short form for domain name system. DNS is like the phone book of the internet. You know how if you want to call someone, you don't have to memorize their phone number. You just search for their names in your contact and your phone dials the number for you. That is what domain name system does for the internet. So when you type www.youtube.com on your browser, DNS translates the domain name youtube.com into the IP address of YouTube so that your computer can connect with the right YouTube server, because computers talk in numbers. But for humans, that can be quite difficult. So imagine having to memorize the IP addresses of social media websites like Facebook, Instagram, WhatsApp. That can be a lot. So DNS just makes things easy. Now, in a DNS spoofing attack, a threat actor spoofs the IP address of YouTube. What does spoofing means? Imitating. They imitate the IP address. So when you type www.youtube.com, instead of sending you to YouTube's actual website, the attacker sent you to a fake or malicious website that might look exactly like the real thing. The goal is to steal information like usernames, password, or even install malware on your device. Website defacement. So this is when someone hacks a website and changes how it looks, usually posting offensive or political messages. You know, one time I ran a blog when I was in school, and I woke up one morning to see a huge banner on the website's landing page that says you have been hacked. One way to protect integrity of data is by using something called hashing. So hashing is like creating a fingerprint for data. You know, like every one of us, we have unique fingerprints. So when you take your data through a hashing algorithm, you get a hashed test, which is like a unique fingerprint for that data. Look at this diagram. This is a plain test. Let's imagine that you type Temitope is a very good girl, and you pass it through this hashing algorithm. What you get is a hashed test or a message digest. So this is like a unique fingerprint for that data. Also, this is what is being illustrated here. When you type hello world and that hello world goes through this hashing algorithm, you get a unique hash test or a message digest for your data. If as little as 0 gets edited from this test, this hashed test or message digest will change. You will not have the same message digest or a hash test for hello world as hello world. The real world, hashing is used to store passwords securely. So when you create a password on a website, your password is not stored as plain text. Instead, it goes through a hashing algorithm and it is hashed. So even the website admin can't see your original password. Only the hash is what they will see. So when you log into that website, the system compares the hash of the password you just entered to the stored hash to verify it. So let's say the day you were registering on the website, you chose your password to be $235. When that $235 goes through a hashing algorithm, it gets like a unique hash. That hashed password or message that gets stored in their database. The next time when you want to log into that website and you type $235, the system compares the hash of your password that you entered to the stored hash to verify it. Let's say you now type $234, the hash should be completely different. That's when you now get password not correct. So it's a way to ensure that passwords are stored securely and they are not tampered with. Another method to protect integrity is what we call digital signatures. So digital signatures are another way to protect data integrity. So it is like signing a document with a stamp. Now let's look at this example. Imagine you're sending $500 to your friend. This is the details of the $500, the amount, your name, who you are sending it to, the account details and all. This is the data. So when it goes through a hashing algorithm, like we talked about the other time, when it goes through a hashing algorithm, you get a unique hash or a message digest. So this is where digital signature comes in. The bank uses a private key to encrypt the hash. So the result of encrypting the hashed text with a private key will give you a digitally signed document. So the bank receives the signed document, that's your transfer request, and uses its public key to decrypt the signature. That's the digitally signed document. So after decrypting it, the bank gets the original hash of your transfer request. Then the bank now runs the original document through a hashing algorithm. So they now get two hashes. They compare this hash. If this hash matches, then they know, oh, truly, while your transfer request was going through the network, it was not tampered with. Checksums are used to verify the integrity of files during transmission or storage. Look at this now. This is input. This is Fox, FOX. If you calculate the checksum of this Fox, this is what you will get. This is another input. If you calculate the checksum, it's a different thing. Now look at this. The red fox jumps. You see that V over has been changed to U. If you calculate the checksum of this, you know that this and this, they look similar, but they are not the same, because here we have over, but here we have OUER. The over has been slightly changed to U. If you calculate the checksum, it is different. It will give you a different checksum. Look at it. It's a different checksum. Now look at this, is another a little tampering. If you calculate the checksum of this data, it will give you something entirely different. So checksums are also used to verify the integrity of data. Checksums are commonly used when downloading software from the internet. For example, when you want to download like a software, let's say you want to download a software like VirtualBox or an editing software, website often provides a checksum. So after you download the file, before you run it on your system, you can calculate the checksum of the downloaded file and compare it with the one that the website has provided. If they match, you know that the file is intact. But if it has been corrupted or tampered with during the download process, you will know when you calculate the checksum, because the checksum will be different, as we have seen with these examples. So thank you very much for watching. I hope this was explanatory, and see you in my